Hey people, this is our first stream on Instagram, so I'm just getting set up here. I did not expect it to be vertical, but we're going to go with that. Hello. Come on in, Edge.
It's me. Hello. Yeah, looks like it's vertical. Wonder why that is.
I need to take a seat.
Sure. Or we can talk in the meantime.
Yeah.
Oh, it looks like it's wide over there.
That's an OBS.
Maybe
This
all
is
live
what-
streams on Instagram are vertical.
I'm just trying to make OBS vertical now.
Ooh.
But it's putting all this stuff on top of each other and...
Wow, that's really frustrating. Take your time. This is our first time doing this. So it's not going to be perfect.
About properties. How about settings? Ooh, stream.
Video. Output. Doesn't work.
It's stuck at this. Oh well, we'll just have to do this today. And there's a pretty good amount of lag.
It looks like it. Ooh.
Whoops.
They don't want to see our ugly mugs anyway, so maybe we should just switch to Doptown.
Switch to what?
Top down. Oh, it's right.
No, it's right there. We just have to put it in the middle. A little more that way. A little more underneath. And the chat is not loading. Okay.
Yep. This is going very well. Misty Estop says hello. Hello. Thank you very much for your educational channel, says Sid. Sierra, thank you for tuning in. Yeah, if you guys have any questions about NLab or us as a couple running a startup.
I wrote in the event title that we're going to talk about capacitors tonight.
That's so much more boring than real talk from founders.
Yes, we could also answer questions about business-related things and education and engineering. But if there's nothing to talk about, we can talk about capacitors.
I do like I do like a good capacitor.
We did some live streaming on TikTok, and I think it got a little advanced. So we could also talk about the microphone here, because there is a microphone built. Get this over circuit some more.
Well, what I think we should do is there's a capacitor in the circuit. So why don't we talk about capacitors in general, and then we talk about what the capacitor does in this microphone circuit.
Sure.
Cool. I think the NLab should be on the screen. I don't know if that's gonna...
That's more real time.
Mm-hmm.
Should be higher.
I just want to show the NLab.
Okay.
I'm going to get really close to you because of the vertical format that we haven't we haven't figured out.
Well, I imagine most people are watching on their cell phones anyway, so we'll probably have to figure out how to make it work on vertical. Okay.
Where are you from? I'm from Chicago. He's from Jersey.
New Jersey. Which is currently covered in snow, and Chicago is not. It's very strange.
I piss him off when I say Jersey because he's not from like Jersey. He grew up on a farm in New Jersey, and I'm a city girl. He's a farm boy.
Okay, get a little closer.
Get a little closer to you.
No, the circuits.
Oh, okay.
Okay, that is kind of legible.
Okay. Capacitors.
Okay, capacitors. Capacitors, when you draw a schematic, looks like this. It's two parallel plates. And we label it C for capacitor. And
Can you even see that? Oh, we're lagging.
It's
That's
lagging,
why.
you can't see it.
I'm like, it's invisible. Yeah.
Yeah, so capacitors are kind of weird in that, so the units are farads. Right, farads. I think for Michael Faraday, who was one of the original scientists who discovered all of the principles of electromagnetism, so when you do cool stuff like that, you get units named after you. So like amp is after ampere, and ohm is after ohm. Volt is after volta. But what's weird about farads is like you would never see 1 farad. Like, you know, you would see 1 volt or 1 amp. That's kind of a normal amount of electricity. You'd never see 1 farad. That's like an unusual large amount. So normally when we're doing farads, we're doing like 1 microfarad.
Which is this weird U shape. It looks like a U combined with an M. It's called mu.
Yeah, mu. But it means 1/1,000,000th. So 1/1,000,000th of a farad is kind of a normal amount, and even less. So this circuit here has, I think, maybe this one only has one microfarad capacitor in it. And it's not unusual to even have like 0.1 or 0.01 microfarads. Having something like more than that typically means you're doing like power stuff. And in this case, we're building a little microphone circuit. We don't need to power things.
We do have a question. Great stuff. Is the kit ready to purchase? What's funny is like we're launching on Kickstarter in about a month, so they'll start shipping soon after that. But like the product is technically ready to ship. The reason we're doing the Kickstarter is because we need to raise money to make the free video tutorials on YouTube. And we have 4 tutorials already on YouTube for you to check out. So if you guys like them, then we'll know that we can keep making tutorials in that style. But your feedback would be really valuable to us there.
Yeah.
But yes, we've been selling these kits to universities for a while. And they're technically ready to buy, but we just need, like, I don't want to call the product complete, you know, until we have a rolling schedule of free video tutorials coming out. And to do that, yeah, we need some help. So that's why we're doing the Kickstarter.
Yeah. But the hardware is done and operational. You can see it right here.
Ta-da!
I'm a professor, and I have right now 65 students using these. And last semester we had 150 students using these, and it's been like that for several years. So pretty confident that everything works and that we have all the right parts. But yeah, the Kickstarters are a way of launching it.
Yep. Great question, and thank you, Anthony. Yeah, keep the questions coming, guys, and we'll just keep talking to you about capacitors.
Yeah.
Now that we know how they're measured, what is the function of a capacitor in a circuit? Like, what does it do?
Yeah, the capacitor you could think of as like a bucket, and the bucket stores like a real bucket stores water, and the flow of water is like the motion. In the electronics world, the capacitor is the bucket, and the electrons are the water, and the flow of the electrons is current. So what we're doing is we're making the ability to like store up electrons, and when we do that, it gets measured in a unit called volts. So the pressure of the electrons being stored is the pressure of those electrons like trying to get out.
Yep.
And that's like the water pressure in the bucket, or the air pressure of a balloon. It's the pressure of the electrons trying to escape. That's measured in volts. And when the electrons do escape, we measure their motion in current, or in the units of amps. And so the capacitor is there to kind of act like a little bucket, which you could think of as slowing things down in a very specific way. So we also have resistors. Resistors directly slow down the current. So when you apply voltage to a resistor, you can calculate the current with Ohm's law, V equals IR. That's like as easy as it gets. And that's usually where we start. And so today I wanted to introduce the concept of a capacitor, which is not a resistor. It doesn't obey Ohm's law. There's no V equals IR. Instead, it's a thing that charges. So you could think of it like a spring. Like we're going to apply some pressure to it, some force, and it's going to store that force like the energy gets stored in a spring.
Nice. Or a battery.
Or a battery, yeah. And so you can think of a capacitor as like a really bad battery. Like a battery can store a lot of charge and provide the voltage for a long time. Capacitors do the same thing, but over very short periods of time.
Right.
So they have a very specific function. They're not there to power the circuit. They're there to add like a little bit of
buffer
or delay.
Yeah. I like the camera flash example. Let's talk about that in a second. For now, we got a comment saying that people are commenting on TikTok and being ignored.
Uh-oh.
Guys, we're streaming to Instagram for the very first time tonight, and we're doing it simultaneously with TikTok?
Not yet. Actually, I didn't turn that on because to stream simultaneously in TikTok, you need...
Oh, so people are waiting for us to stream on TikTok, but we're on Instagram.
Yeah, TikTok, you need permission from TikTok to stream on both places. And so I applied for permission, and we're waiting for them to say yes.
TikTok, come on.
And we could have also been streaming on YouTube. I didn't turn that on either. There's just a lot of new things going on right now, so I was like, well, let's just try one thing.
Bubble Bath 125, so sorry for not responding. If you have a question, please put it here. We're so new at this. We have no idea what social media is, and Nick has done an amazing job at figuring it out on the fly.
We're getting there. We have a really nice top-down camera in this particular studio, but there's a setting that's wrong, so I'm using our little document camera, which isn't...
This is all going to be better someday.
Yeah.
Oh, I can see TikTok stream. It's on live right now. You did it!
Oh.
Yay!
Good for me.
How did you do that? We're on TikTok and we didn't even know it. I can't wait to see those comments being like, guys, you're on TikTok right now.
We're using OBS to do this. This is like a common way to do it. Can
you just go to TikTok?
You can see that TikTok is not on and YouTube is not on, but Instagram also says offline, so
wow.
Maybe we're on all three right now.
This is a very confusing platform.
The chat won't load, so I can't see anything.
Can we just go to the TikTok website?
Yeah. I'm watching the comments in Instagram.
Yeah. Like we're logged into our own stream.
We're watching ourselves.
Yeah. This is very sophisticated. And sure as shit, there we are. Wow. That's fantastic. And sure as
oh, there's less lag.
There it is. You are on TikTok.
And it's widestream. This is very confusing.
You know what? Let's just go back and forth for tonight.
Yeah.
Guys, this is what startup founding is like. You try things and you screw up and you laugh and you have so much fun all the time. And there we are on YouTube.
Nice.
Fantastic.
Just going to rack the views up here.
We did it. That's an old one. Why did you think that was me?
Oh, and look at this fun title it made.
Stream via RTMP with Restream.
Yeah. Okay, we're advertising for Restream right now.
Can we just get back to... I'm surprised if anyone's still watching. Let's see. I can see TikTok stream. It's on live right now. TikTok, YouTube, and Insta. Great. I'm the guy with the funny squiggly name. Yeah, I see you're live on TikTok too. It's vertical on Insta, but horizontal on TikTok. We're just going to roll with it, you guys. No one's getting hurt.
We'll fix that tomorrow.
Yeah, no one's getting hurt.
Unless you like it vertical.
Do you like the inconsistency? If so, we'll keep it. The customer is always right.
Well, we can make them all vertical or all horizontal.
Ooh. But, okay. All right. Let's go. Okay. Talk about the camera flash example with capacitors. So
right.
It doesn't camera flashes don't work the same as they used to, but what were capacitors used for old-fashioned cameras?
Right. So let's say you have a 6-volt battery,
Mm-hmm.
and when you apply 6 volts to the LED, or those might not have been LEDs back then, they might have been incandescent light bulbs.
Mm-hmm.
But when you applied the voltage to them, it would do a V equals IR style equation, and the I would be very, very high, like 10 amps, a very large amount of current. And the battery wouldn't actually be capable of delivering 10 amps. So we usually write V equals IR assuming that the thing that provides the current, the voltage, is capable of giving that current. But that's not true. Like a little AA battery, when you short circuit it, you can only get up to like 3 amps. So the idea behind a big capacitor circuit in the flash, this is like nobody has this anymore, but you have this big bulb on top of the camera and go boom, flash.
Yeah, you guys ever see those old movies where like when the flash goes off in a camera, it's like its own separate thing and it like blinds you and they have to like reset it every time because
and they still have it. If you go to a wedding, there's usually people, but now they put them on poles rather than being on top of the camera.
Yeah, I've seen that. It more looks like they're trying to start a fire in old movies or something. Anyway.
So anyway, you would have this little battery and maybe it only has 1.5 volts. And so you'd be like, I really wish I had 12 volts and I really wish that 12 volts could deliver 10 amps of current. So there'd be a circuit that would double and then double and then double the voltage from the battery to go from 1 volt up to 12 volts or whatever it needed. And then that capacitor would be capable of delivering that current, the energy stored in it, instantaneously. But it wouldn't have that much total power in it. So the flash would only be on for like a split second, which is what you want for the flash anyway.
Yeah.
So what you're doing is you're trading slowly stealing energy from the battery and then delivering it in an instant.
Yeah.
Because it's the same amount of power over time. It's just that the LED only needs to be on for like a millisecond.
Well, I think that rolls perfectly into Bubble Bath's question, which is, can you control when a capacitor releases energy?
Yes, you have, certainly once you put power into the capacitor, you can use switches to apply more power to it or get the power out.
And that's what the old-fashioned like this thing was.
Yeah,
right?
yeah, and they probably didn't use electronics even. It was literally switches and just shorting. And so
switches was like a small piece of wire coming down to meet the other two wires.
In this case, though, special switches. Because I watched working with one of my professors once, and I think I was probably his teaching assistant, and he was going to do a demo in class with taking out the really large capacitors out of this flash unit to demonstrate what happened, when you short-circuited them.
Mm-hmm.
And, you have to be very careful when you do that. There's a lot of energy in there, like enough to hurt yourself. And he was pretty confident that the capacitors were uncharged. Like, it had been sitting in his desk for like a year. He hadn't used it. But he wanted to make sure when he touched it, it didn't short circuit through him. So he took a screwdriver out and he touched like this between the two prongs of the capacitor, and it literally blew the tip off of the screwdriver. Like, the current was so much that the metal of the screwdriver got hot and it blew up, which was very comical and unexpected. And we were both like, maybe we shouldn't give this to 100 undergraduates to play with. So the switches in those were actually special, so that obviously, they're metal too. If you just short-circuited the capacitor, it would blow the switch up, and then you never get to use the switch again. So I imagine they were special, and they had maybe some inductor in them to limit the current, stuff like that.
Okay, I just have to say really quick that I'm cycling through YouTube, Instagram, and TikTok, guys. Like, if you see me reaching for the computer, that's why. We're getting a lot of funny comments on TikTok being like, what's going on under that table? We're never going to see your right hand after this. I don't blame you, because if you go on Instagram, we're in a vertical orientation, which means me and Nick have to be probably closer than we've ever been in our relationship. And it kind of looks like I'm gonna eat your face or something. So like when we're on widescreen, people are probably
don't get to see our hands.
Yeah. So I'm trying to stay on screen on Instagram, but yes, also you can't see my hands, so who knows? Ooh. if you guys remember me at all, but I came last week and I'm Peter. Ah, I do remember you. Hello again, Peter. Let's see. Very scary. I'm a biomed and working with defibrillators are very dangerous. Very big caps.
Yeah, so do you know the defibrillator?
Yes, of course I do. But I can't say it right.
Defibrillator. Yeah, that's got to apply a current across your chest at a very specific moment in your heartbeat. I think a lot of people watch medical dramas and they see this thing where it's like a person's heart has stopped, so let's shock them to start it again.
Clear.
Yeah, and that's not true. What's happening is your heart is still beating, but it's beating out of order, so that the blood is just sloshing around inside of the heart. And what you need to do is you need to give it an electrical reset. So when you shock it, you know basically that thing is monitoring your heart, and it sees that the cylinders, you know, if you want to think of it like that, are firing out of order, and then it waits for the right moment to hit it to like get them back at the right time. If someone's heart stops, you have to do CPR. You have to make their heart pump. The defibrillator and the instructions on the defib would, I think, instruct you to do that. But it would also say like, hey, don't touch the person while this is going to happen, because it's going to apply a big voltage to them to get the current through the chest, and you don't want to touch them when that happens.
Totally.
Yeah.
Happy to take more questions. We're checking all three, guys. We're alternating, so don't feel left out. This is our first time at this, and it is messy.
What's funny is we have two giant monitors in front of us that are off. We could have all of the things on, but maybe next time we'll put it on the iPad.
But I'm blind, so I wouldn't even be able to read the comments if they were on the monitors. Does a capacitor let like more power accumulate to then release it all at once, so it's a bigger amount of power?
Right. So that's the difference between, I guess, power and energy, right? Energy is measured in like joules. And so you could measure joules in like, I took a mass and I lift it on the desk, and because it's M times H, we get a number of joules of energy. But power is how quickly do you release it? So power is energy per second. So if you slowly let the mass down, or if you let the mass just fall. And so the same thing with the capacitor. You put a certain amount of joules into the capacitor, and then if you put 1,000,000 ohms across the capacitor, it just slowly leaks the power out over time. Whereas if you put a 1 ohm resistor or 0 ohms, it goes like very, very fast. So it's up to you to choose that amount of power. Now, that's like the ideal world where the capacitor only behaves like a capacitor. And so really a capacitor probably has a little bit of resistance to it, and that resistance might not be constant. So when you slowly take energy out of the capacitor, you're getting most of the energy back out. But if you quickly take it out, it might heat up the capacitor, and then that energy that's heating up the capacitor is lost energy. So different types of capacitors do better at that. The capacitors in our circuit right here are called ceramic capacitors. They're little, they're beige. They come in small numbers like 1 microfarad. They have very little resistance. They call it ESR, or equivalent series resistance. But you can't get them very big. So if you wanted a 1 farad capacitor, it doesn't come in this type. That comes in the bigger cylindrical style capacitors you might have seen in a power supply or a quadcopter or something like that. Those ones are usually technology called aluminum. But they can have much higher capacitances, a lot more energy stored in them. But the penalty for that is they have much higher resistances. So if you're like worried that you're trying to get 100% of the energy that you put in back out again, you'd want to use a little capacitor.
Hope that answered the question.
Yeah, probably fascinating details into capacitors. Also, the aluminum capacitors are usually polarized. So if you ever see a capacitor where one leg is longer than the other, that's because if you hook them up backwards and apply a big voltage, they will explode.
Ah.
Yeah, or not explode, but they'll kind of pop and this goo will come out.
But these are not like that, right?
These are not like that, yeah.
Thank goodness.
Right.
We could call this a test night.
Well, how about I add a window in OBS like I'll open up the NLab app and we'll just practice that part too, because sometimes we want to show people what the NLab sees. And so right now we have a microphone circuit built on there, and I kind of want to show it off. Oh, this program's not fun at all.
No, it doesn't look fun at all. It doesn't look intuitive at all.
Add a
For the one person watching this, thank you for staying on.
screen capture. Now we have a
For the
microphone
one person
circuit
watching
built on
this,
there.
thank you for staying on.
I capture. And oh my god, I have so many
I
windows open.
I hope someday when we have this down pat, we can look back on this first stream and laugh.
I'm sure we'll have many other fun streams.
I hope so.
Okay.
Well, it's over our faces,
Yeah,
but who cares?
but we need it to be fit in that silly vertical thing.
I don't. Yeah. Oh, I see.
Okay.
Okay. Boop, boop, boop. I'm touching the microphone.
TikTok updates really fast. YouTube is lagging a little. Instagram lags a lot. Oh, now it caught up. Okay, so that works nicely.
Mm-hmm.
So this is a microphone circuit. And so for people who are checking in, they're like, what is going on? Angie and I make NLab, which is a kit that teaches you how to design and build electronics. The NLab itself is a device that lets you see electricity, so voltages. And that's what this window below us is. It's showing us 4 different signals coming from a microphone circuit. The green line that's kind of high up there is the raw output from a raw microphone like chip. And then what we have to do is we have to build a circuit so that it turns it into a sound that is usable and understandable. And so below that green line you see a blue line and a red line. And the blue line is the raw sound with a lot of noise on it. So if I stay quiet for a second, it's kind of fuzzy.
Yeah,
and then the red line is that signal with a filter, I think. Oh no, maybe the red is the raw before the amplification, and the blue is the raw signal. And then we have not tried to remove the noise yet. So the fuzziness of blue, if I stop talking and it's still fuzzy, that's kind of undesirable. That would be if we recorded this, it would sound like the hiss sound of a bad microphone. That's what this guy's doing. And so that's what we try to do with our NLab, is teach people how to design and build things. Now I've zoomed in, and so if I whistle,
Can we not whistle? Can we hum?
I forgot that the whistling was too loud.
Yeah. Not too loud for me. We got feedback from you guys that it's too loud for you.
We see the sine wave, right? Because whistle is like a pure tone. It's a pure sine wave, and that's why it's so piercing. But the sound that's coming out of my mouth is a combination of many frequencies. So if we get it to the right setting, we could kind of see the individual frequencies of my voice. And if we go slower, we kind of see the signal versus time. As I get louder, we see it jump up and down. So building the microphone circuit is a lot of fun. And that's the type of thing that we're going to be doing on our live streams and in our content on YouTube.
In a much more organized manner. This was congrats on attending the test run, y'all.
Yeah, thank you for coming.
We'll print t-shirts for you. I survived the first NLab live stream.
Multiple channel live stream.
I think it would be a more productive use of our time if we, I don't know, y'all can stay on for this if you want, I guess, but do you want to try to fix it?
I think when I made the Instagram link, there was probably an option to be widescreen or vertical. So we'd have to turn off
well, then let's
Instagram.
just try it again tomorrow.
Yeah, we'll try it again tomorrow.
Yeah, okay.
We'll try to get that right. And so we're going to stream every weeknight from 8 to 9
p.m. Central.
And we're here to answer questions about people who want to know what is an NLab and what's it like being an engineer.
What's it like? What's it like working as a professor? I worked in the robotics industry for a while. Nick is very close to the job market right now because he's got lots of students asking him about it. Ask us how we feel about AI. Ask us what it's like working as a married couple on a business. Like, ask us about the Kickstarter. Like, we're here to answer any and all questions. Well, not everything. Not not everything.
Yeah, you might be able to hear we have a little dog and he's barking because he's angry that we're not playing with him.
He'll make a cameo in a video soon. I'm really excited for you guys to see it. It's really freaking cute.
Yeah.
Are all capacitors directional? That's a good question. Okay.
No, typically only ceramic capacitors, little normal sized capacitors are directional. The big ones, when you see something like 1,000 microfarads and it's usually comes in a cylinder and it's usually blue, those ones are directional. And usually you could tell it's directional because one leg is longer than the other, or the body has a little stripe on the side. That's the minus side. It's like literally the minus sign. Yeah, we'll do capacitors again.
And the banana cake that you're baking is ready, so I think that's a sign.
Oh, that's the sign.
All right, y'all. Thanks for coming along on this journey. We promise we'll have our stuff together.
Yeah.
How does the discount work? If you got the $1 pre-order thing, are you guys going to send like a discount or something? Yes. That's like, you guys are part of a special club. You're going to be getting your own exclusive emails coming to you, and you will get the 20% discount. Yeah.
Yeah,
guaranteed.
that's part of our Kickstarter launch campaign.
Yes.
So you'll be guaranteed a spot at that price level.
And guys, if you feel like getting 20% off, yeah, please place your $1 reservation soon, because there's only so many N Labs we can apply that to, and they're going fast.
Mr. Stop has a question. Go for it.
Go for it.
He says, don't go yet. I have a question.
That's a very good sign. People don't want us to leave.
Yeah.
They love us. They really love us, even when there's technical difficulties. Mistia, stop. Oh, Don Cluster has a question too. Okay, I guess we're staying. You know, but your banana bread's gonna burn. Do you want to go get it?
Okay, I'll do that. You answer all the
I'll
questions.
answer the questions. God bless you all. Here I am. Pyre 8 Dude 781, good evening. Electrolytic. Yes, I agree. Guys, don't tease me. Okay, wait, bye-bye, have a great night, and yes, you guys are so fun. Oh my gosh, thank you so much. But wait, we're not leaving yet. We had 2 people saying they have a question. Mistia Stop and Don Cluster 5. Your call is very important to us.
I need a little bit more time.
Is it lagging or? Sorry, not the cake.
Yes, the cake is lagging. It's related to our internet speed.
I was wondering if like they asked their questions and we're not seeing them yet or something.
No, they might be messing with us though. They might be like, no, don't go.
Oh, I've been punked. How soon do you expect to be shipping? The kit is all done. Like we can basically, like, we have to place the order for the parts, but right now it's looking like, you know, we launched the Kickstarter in April, and then we can start shipping a month from then.
Yeah, I think especially the pre-orders, the people who are getting in early, they will get theirs sooner.
Yeah.
Because we have some that are half ready to go, and then everybody else, depending on how well we do, you know, we'll have to order a big batch, which is going to be very exciting, and I expect we'll have everything to everybody by the end of August. Like, that's my thought.
Got it.
Is like, I would like to be done with that in August because we have other plans.
We did get a question. For example, what type should I use for filtering?
Filtering, yeah.
And could you use banana bread as a resistor? You technically could. Anything is a resistor if you believe in yourself.
I just saw a fun YouTube short going around. Someone who, you know, usually people who are audiophiles, people who like listen to audio and they're like, I hear really, really well. They're like super tasters, but for sound.
Ooh.
And so somebody like forced the signal to go through different things and asked them if they could tell like if the signal was bad or not, and they couldn't. So like they put it through a banana. Like they literally plugged the wires one side in the banana, the other side in the banana, and the sound, the person could not tell the difference. And it's, you know, like funny that anyway. Capacitors. You want to probably use a small signal capacitor for filtering small signals. So if the voltages are like less than 10 volts, you're probably using 1 microfarad or smaller, using regular ceramic capacitors.
Translate that for me. Like in the real world, what would like small filtering look like?
Small filtering is like we're doing the microphone, we're looking at our pulse, we're taking little square waves and making them smooth.
What about big filtering?
Big filtering is a radio person, and there's all these radio people out there who build high power electronics because they are ham radio enthusiasts, right? So they're outputting pretty good chunks amount of power, and those capacitors tend to be much bigger, and they're also usually pairing them with inductors to build very interesting resonant filters. But they're big junky, like the size of a mug capacitor.
Okay.
Not what we're doing here. What we're doing here is small signal electronics, Arduino, Raspberry Pi style electronics. We're not ham radio enthusiasts yet.
Is it accurate to say that the like big capacitors you need for like high filtering is like proportional to the amount of power in the application?
Yeah, the physical size of the capacitor is usually related to how high the voltage will be. And so all the capacitors we put in our kit are safe up to like 50 volts at like the small amount, like 1 microfarad. When a capacitor is like 1 farad and many volts, it's going to be a big one.
Got it.
So anyway, the capacitor filter is usually a pair, though. It's a capacitor with a resistor. So usually the more interesting question is, how do I know which resistor capacitor pair do I use for my filter? And we'll have a whole video on that.
Great. And speaking of videos, we got a question from Pyre8Dude781. Will you be doing basic electronics lessons online? Yes. If you want to check out the vibe of our basics electronics lessons, we have 4 of them posted, 4 tutorials, and they're each about 10 minutes long, and they're supposed to be beginner friendly.
Right.
Now, where we need your guys' help is to tell us if those videos are indeed good and if they are beginner friendly, because Nick and I are both robotics engineers and we both have the curse of expertise. We do our best to make things as simple, and we just want to make sure we're fulfilling our mission that like anyone can become an engineer. But it's a little hard when you have tunnel vision and you kind of know the concepts already. Right. So, yeah. Oh, how do I know what type of capacitor is better? I think we only saw the second part of your question for some reason.
Right.
Like I think you replied to yourself, and that's all we saw. Better for certain applications. How do I know if I should use aluminum, electrolytic, film, or ceramic?
Right. So if you have a specific like application you're going to use, there's usually a like let's say you're building a voltage regulator or an audio amplifier. Those PDFs, the spec sheets, actually usually recommend the type. So that would be your first clue. Would be the data sheet for the thing you're trying to build says what to use. I would always follow that. Sometimes they'll give you the exact part number to buy on DigiKey as well. But if you don't have that, then you're basing it more on the size of the capacitor. If it's over 10 microfarads, it's probably aluminum. We used to use tantalum for middle range, like 0.1 to 10 microfarads, but those aren't as popular anymore because tantalum's like a conflict material. So instead, the ceramic ones are now anything from like 1 picofarad up to 10 microfarad. And then the film type, I think, is just they might have different temperature ratings. So if you're going to build something that goes in a car, usually the temperature rating for all the electronics is larger because cars can get pretty hot, pretty cold, whereas basic electronics don't get that hot or cold in comparison. Got it. You want to look at, is there a weird temperature range? Is there a weird voltage range? Is it like bigger or less than 1 microfarad?
Cool. Yeah. I think that might be a good place to stop. I hope we answered everyone's questions. If we didn't, we'll be back tomorrow.
Yeah.
We're going to go eat some banana bread. So good night, everybody.
Yeah. Thanks for coming.
Bye.
Now we just have to figure out how to stop it.
There's like 10 windows open.